I'm Mr. Richmond. This is your Unit 10.1 lesson summary. In Unit 10.1, we will begin our study of geometry. We're going to start to look at distances on the coordinate plane, how to calculate distance of segments and distance between points. We'll get into translations, which is one of our type of geometric transformations. And we'll start to get familiar with the use of a compass in geometry and in math to perform construction. So it's a little bit of everything here in this first section. So it is real important that you look through the book for this section because you do a lot of great things with developing the formula for distance, things like that, using your prior knowledge on Pythagorean theorem. For this lesson, I'm just doing a summary, so I'm really just going to kind of jump right into giving you that formula, but it's important that you go through the book and see how exactly that formula is worked, and I'll try to kind of briefly touch on that. But ultimately what we need you to be able to do by the end of this section is find the distance between 2 points. So if I had these 2 points graphed and I wanted to calculate the distance, and the problem would be that if it's a slanted distance, I can't just count boxes. That's kind of our first mistake. We feel like we can count slanted boxes, but it doesn't work that way. I can only count distance when it's horizontal or vertical. So when it's slanted, I'm going to need a formula for that. The formula for distance is the square root of x sub 2, so my second x coordinate, minus x sub 1, my first y coordinate, squared, plus parentheses, y sub 2, my second y coordinate, minus y sub 1, my first y coordinate, squared. And ultimately, what you're doing, if I can just kind of give you a quick visual of that, if I had 2 points, I'm trying to find the length here, I could use the Pythagorean theorem because I can turn it into a right triangle. And when I'm talking about coordinates here, horizontal distance is represented by the distance between your x values. So really the distance of A in the Pythagorean theorem here would be x2 minus x1. And since the Pythagorean theorem looks like this, equals c squared, to solve for c I'd actually be just doing the square root of that. To find that distance c of the hypotenuse, x2 minus x1 finds that a value that would go there, whereas b is a vertical distance, would find the distance between the y coordinates, y2 minus y1 would represent b squared, and then in the final product of solving Pythagorean theorem problems, you have to do the square root. That's where that square root function comes into when they create the distance formula. So if I have a visual, probably Pythagorean theorem is still going to be your best bet because you can just make a quick right triangle out of that and plug it in, and I'll show it that way maybe for problem B. But when it's in coordinate form, for a lot of people, just plugging it right in the distance formula is a little quicker because it's in this coordinate notation. So let's try that now. In order to do that, I need to label the points. I'm going to make the first coordinate x1, y1, the second coordinate x2, y2, and I'm going to plug this into the formula and find the distance. So x sub 2 is negative 1, minus x sub 1, which is negative 6. And this is where you need to be careful because you might have some subtracting negatives going on and need to zip zap. So you need to be real careful with your arithmetic. See, I already mixed it up. I did the y's there. So I should have done x2 minus x1. x1 is negative 6. x2 was 5. You can do this all day and still make mistakes. So it's you have to be real careful about holding things and matching up in the right spot. x2, 5, x1, negative 6, minus 6. Now I got it right. y2 is negative 1. Minus y1, which is 4. Squared. So be real careful there. Now I can do my arithmetic. Zip zap would change it to 5 plus 6. So it's going to be 11 squared plus negative 1 minus 4 is negative 5. So it's going to be negative 5 squared. 11 squared is 121. Negative 5 squared is positive 25. So what's important you notice there is that it always ends up being positive numbers because of that squaring. And then 121 plus 125 is 146. And I have my answer, the square root of 146. Now I can approximate that with a calculator. Some teachers might want you to leave it in a root form, just depends on what they want. Square root of 146 when entered on a calculator is approximately 12.08. So the distance between those points is close to 12. Good. Okay, letter B here. Same idea. I'm going to try to find the distance between these coordinates. And I could find the coordinates of these points, 1, 1, and looks like 4, 6, 1, 1, and 4, 6, and do the distance formula. But since I have the visual, it's not a bad idea to just turn this into a right triangle and do Pythagorean theorem, since I can easily count horizontal and vertical distances. So my horizontal distance is 2, 1, 2. My vertical distance is 1, 2, 3, 4, and 5. So I could just do Pythagorean theorem here for 2 and 5. So you can still use those skills for distance problems. So I'm going to plug these in. 2 squared would be 4. 5 squared would be 25. So it's 4 plus 25, which is 29, which means my distance is the square root of 29. And I left it c, a squared plus b squared equals c squared, because that's our normal Pythagorean theorem. And then I changed it to a d to represent distance, since that's the variable we typically use for distance. And I can again approximate that by entering it on the calculator, or leave it exact and just leave it as the square root of 29, so there's no rounding involved. That is approximately 5.385, which I will approximate to 5.4. So you need to be able to do distance problems when I give you a graph, put in coordinates, and just be able to do them when they're simply written as coordinates. Okay, now we'll move on to a translation. A translation is a type of transformation that we do in geometry that shifts or moves a shape left, right, up, down, or diagonally. What you need to know about a translation is it cannot change the visual layout of it. If this is my shape, it can't change how it looks via any sort of rotation or up and down kind of reflecting or horizontal reflecting. It has to just slide. The shape itself can't look any different. It just has to move around. So this is me translating my hand because nothing's changing. Okay? So to translate a segment or translate a point, translate anything, you just move it however it's supposed to translate. With a segment, if I just move the A and B and put those in place, every other point along the way will move in the same way. So I could actually just move the A and B and then draw my segment. And that's the way I'm going to do it. So they want me to move 3 units to the right. So I'm going to go 1, 2, 3, and down 4 units. 1, 2, 3, 4. And anytime you make a new image, when you do any sort of translation, transformation at all, you want to use a prime. B prime, this is the new image, this would be the pre-image. And I'm going to do the same for A. It's going to move right 3, 1, 2, 3, and down 4. 1, 2, 3, and 4. And now I can just connect those, and I've translated the image. Let me show you what that does to the coordinates. So the coordinates of A were originally 1, 3. The coordinates of B were originally 2, 3. Let's say 3, 5. Well, a translation right will change all the x values because x is left and right. So you should see these increase by 3. So I can know the new coordinates by just adding 3 to the x values. And a shift of down 4 should change the y values by subtracting 4 to them. And if I check my coordinates, 1, 2, 3, 4, down 1 matches A prime, and 6 and up 1 matches B prime. So you can just write the coordinates and translate the coordinates and plot it, or you can count it on the graph. It's kind of your choice there. Okay, and lastly, we're going to teach you the basics of using your compass and translating a shape. So this is my whiteboard version of a compass. This would be my pen. This would be my pencil for you guys. You can open it up to whatever size you want, and then most of your compasses have a locking type mechanism on the top. It's usually a little switch that you can flip to the left or the right to tighten it. Some maybe have a little screw type action going on there. So to duplicate a shape, I just use the principles of a circle. Every point along a circle is equidistant from the center. And so if I set my compass to a particular radius that I want, I can draw a circle or an arc, and any point along that circle or arc would be equidistant to whatever I set the compass to. And that's basically it for duplicating a segment, is you draw your new segment wherever you want it. So I'm going to put mine here, E prime, and then I just have to draw an arc off of that E prime that's equidistant to EF. So let's do that. Hopefully mine will work okay. This thing's kind of a little old here. So let's put my point on E. So I'm putting the tip of my compass on E and my pencil on F. That's how you guys would do it. And for this one, if you're trying it at home, just draw your own segment, whatever length you want, and then try to duplicate it. So now that my compass is set to that length, any circle I make off of that will give me a point that would keep it equidistant. And I can just draw an arc off of that new image. And now any point I put on that arc will be the same length as EF here once I draw it. And so you just put it where you want it. I want mine to be kind of straight like the other one, kind of horizontal, so I'm going to put it there. And now I use my straight edge, my ruler, my protractor, and I connect E to any point on that arc, and I call it F prime, and I've now duplicated that segment. In this first section, that's the only construction we're really going to get into. The book lets you do a little bit more with that, draw some circles, make some kind of cool designs, get comfortable with using the protractor. It's a tool, like a hammer or a screwdriver. It's just a mathematical tool. Like any tool, you've got to learn how to use it. You've got to practice with it. You might not have the finger dexterity to do well with it at first. Practice, 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 because you'll be doing a lot of constructions over the next couple of chapters. First one will be duplicating a segment, which we did there, and then tomorrow we'll get into some different stuff. So, all right, hopefully that helps. Good luck. See you next time.